Okay, hello everyone. In today's video, we will be going over the solution for the problems 1 to 5 from the recently released problems in the 2023 AMC 10 math competition. So let's start from the first problem. So it says that there are two cities, A and B, that are 45 miles apart. Alicia lives in A and Beth lives in city B. Alicia bikes towards B at 18 miles per hour. Leaving at the same time, Beth bikes towards A at 12 miles per hour. So it asks for how many miles from city A when they meet. So to do this, let's draw a diagram first. So let's represent this as city A. And then the opposite end as city B. Okay? And it says that the distance is 45 miles, so we'll write that. And the speed of Alicia biking towards B is 18 miles per hour. So it's towards this way, 18 miles per hour. And Beth bikes towards A at 12 miles per hour. So let's represent the value of time as t. Okay? So with this, we know the total distance A travels. Here, let's just say it's this distance. Okay? This distance, it will be 18t, and t is in hours. And then we can just write an equation, and then the distance for B, for a more accurate drawing, we can make this longer a bit. And then this will be B, okay? 12t. So the total distance we can see is 12t plus 18t, and that's going to be equal 45 miles. And then simplifying, 30t is equal to 45. Now, it's basically solved now. We just saw for t is going to be 3 over 2. It might make it easier to represent as 1.5. So it asks for the miles from city A. So we're trying to find the value of 18t right here. Okay? So the value of 18t is going to be 18 times 1.5, and that's going to be equal 27. So the answer will be E, 27. Okay, so that's the first question. Now moving on to the next question. So the second question, it says the weight of a third of a large pizza together with 1/3 cups of orange slices is the same weight as 1/4 of a pizza, 3/4, of a pizza together with a half cup of orange slice. And it tells you that a cup of orange slices weighs 1/4 of a pound. It's asking for the weight in pounds of a large pizza. So to do this, let's write an equation. And it's not usually to do operations with mixed fractions. So let's just convert the 3 and 1/2 to 7 over 2. Okay? And we don't need to look at this now. So basically, we just need to write if P is equal to pizza, so the weight of a pizza, O is equal to weight of an orange, a cup of orange. Then basically, 1 over 3P plus 7 over 2 O is equal to 3 over 4P plus 1 over 2 O. And from the equation, from the question, we know that O is going to be equal to 1 over 4. So now we can solve this. So now we just substitute the values of O into this. So it will become 1 over P plus 7 over 2 times 1 over 4. That will be 7 over 8. Equals to 3 over 4 P plus 1 over 2 times 1 over 4. So that will be 1 over 8. Now we just need to simplify the P, right? And then now we just after getting this value, we will solve it to be 5 over 12. P is equal to 3 over 4. And from this, we can see that P is equal to 3 over 4 times 12 over 5. And then that will be simplified to 9 over 5. And because the answer choices are in mixed fractions, we need to simplify it to 1 and 4 over 5. And that's going to be our answer A right here. Okay, moving on to the third question. How many positive perfect squares less than 2023 are divisible by 5? So one concept you need to know here is that every perfect square, it has a prime factorization with only even exponents. Okay? So think about this. When you know this information, how would you do it now? Okay. So the perfect square, let's say x, it must equal to P1, and then this right here must be an even, like 2, 4, 6, and so on. P2, this is N1, N2, P3, N3, right? And these exponents all need to be even. So let's see, because it says it's divisible by 5 right here, in order to make it divisible by 5, one of these, it must be divisible by 5. And since we know it's even exponents, one of them must be at 5 to the power of 2. Because that's divisible by 5, and it's the smallest number with the exponents that has an even number. Okay, so basically we just need to get the x is equal to 5 squared a. And a can be any number that is a square. It can be 1, 4, 9, 16, etc. And this will be 25a. And we are given it needs to be less than. So we'll write an equation less than 23. Okay? And then now we just need to solve this inequality now. Okay? Now, so basically, we're going to write a is smaller or equal to 23 over 25. Okay? And basically, solving this, we will get, you can just solve it as usual, and then we'll get a is smaller than 80 point something. We don't really need to know what it is because it's asking for how many numbers for a as a number square, right? So like a perfect square that is an integer cannot be a decimal. So we'll neglect this for now. So if we neglect this, we need to say a is smaller or equal to 80 because it can be 80. Now, because we have the condition that a must be be a perfect square, right? Must be a perfect square. So perfect square, as you know, it will be 1, 4, 9. And how many are there up to 80? As far as I know, the greatest one will be 64, and that will be 8 squared. So we basically need to find the number of squares from 1 squared to 8 squared, and that will be 8. So the answer will be A. Okay, now moving on to problem 4. A quadrilateral has all integer side lengths, a perimeter of 26. So let's highlight that. Its perimeter is equal to 26, and one side, let's call that A, is equal to 4. What is the greatest possible side length of one side of this quadrilateral? Okay, so to solve this, basically, think of the triangle equation you might have encountered before. So in each triangle, this can also be like a not a right triangle, something like this. Like, let's call this A, this B, this C. There's an equation that A plus C must be greater than A plus B must be greater than C, A plus C must be greater than B, and B plus C must be greater than A. So now, knowing this, we can also, it's true for a quadrilateral. And this is also a theorem. So we can say that in a quadrilateral, A plus B plus C is greater than the fourth side length, D, okay? And then now we can just say that because we know one side is 4, like there's 3 other lengths of it, and we know that this will add up to 26 minus 4, 22. So let's call this the greatest one G. You can call it any variable, but I'll just call it G. And then I'll call the sum of this to A. So G, it's asking for the greatest possible value of G. So based on this equation here, we know that 4 plus A is greater than G. Okay, we also know that A plus G is equal to 22. So we know that A is equal to 22 minus G. Now we just need to substitute this value for A. So 4 plus 22 minus G is greater than G. We get the equation 26 is greater than 2G. So G is smaller than 13. Since it's smaller, G can only be 12. And that will be answer D right here. Okay, now moving on to question 5, our last problem for today's video. How many digits are in the base 10 representation of 8 to the power of 5 times 5 to the power of 10 times 15 to the power of 5? Once we receive these problems, we immediately need to find the prime factorization usually. Okay? And to do this, we need to just expand it. So 8 is equal to H3, and so we need to remove this 8 to H3. 5 already prime, so that's good. So this will be 2 to the power of 3, and then this 15 right here, it's also not prime, so we need to expand it to 15 is equal to 3 times 5. Okay? Now we can rewrite this to 2 to the power of 3, 5 times 5 to the power of 10 times 3 times 5 to the power of 5. So this will be 2 to the power of 15 times 5 to the power of 10 times 3 to the power of 5 times 5 to the power of 5. This will be equal to 2 to the power of 15 times 5 to the power of 15 times 3 to the power of 5. Okay? So, how many digits? The easiest, you of course can't expand it to, you can't like say 2 times 2 times 2 all the way do that. You need to use a good method. And one of them, you immediately see 2 and 5. And when you see when you think of 2 and 5, you think of 10 because 2 times 5 is 10. And when you expand these two, it will become 10 to the power of 15 times 3 to the power of 5. That's way easier. So you know in this, there will be how many digits? For the 0 place, there will be 15. We don't worry about the 1 right now because it is still this number. So 3 to the power of 5 after calculations is going to be 243. You actually don't need to solve it, but you just need to know how many decimal places. But it's a small number, so it's also easy to solve it. It's going to be 243 times 10 to the power of 15. So in this one right here, there's 3 decimal places, 3 digits, I mean. And this has 15 additional digits for the zeros. So, the number total of digits is 3 plus 15, and that's going to be equal to 18, and that's our answer E right here. Okay, so that's going to be it for today's video, and keep in tune for the next video of the problems from 6 to 10, and see you later. Bye.